Plasma Accelerator, QSPA, Higgs Particle, Quasi-Steady-State Fusion, Atlas, WOW, lines 10A, 18A, and 22E. Again, this is a cross-referencing. You see that I'm talking about the lines from the WOW alien signal, and I'm cross-referencing it with the Higgs boson information from CERN and Atlas. Okay, so this one has to do with Atlas. So I'm going to Google Plasma Accelerator QSPA. Up comes, quote, quasi-stationary plasma accelerators and their applications from isopscience.iop.org, from V.I. Tereshin, 1999. The main physical principles of quasi-stationary plasma accelerators, which are capable to generate super high power plasma streams in long pulses. So of course those are called what I call keywords, right? So there's the Google link there. So I'm going to quote the data from V.I. Tereshin, 1995, Plasma Phys Control Fusion. Again, he's talking about accelerators, and here's the abstract for it. The main physical principles of quasi-stationary plasma accelerators, which are capable to generate super high power plasma streams in long pulses, are discussed. The description of QSPA type devices in use in recent experiments, as well as characteristics of the plasma flow in the main acceleration channel and plasma parameters achieved at the outlets of QSPA, are presented here too. Finally, some possibilities of such accelerator applications for fusion and results of their use as diverter plates modeling experiments are described. Okay, so that's what their experiments. It's from 1995, and that's from isop.iop.org. Next is from RasJPhys, dx.doi.org from 2002. Powerful quasi-steady-state plasma accelerator for fusion experiments, with a long list of doctors here. And it's from Science and Technology, Ukraine, Russian National Center, Moscow, Russia, and Germany. Okay, so it's a collaboration between several people. So this was received June 26, 2001. So this is a quote: the full block quasi-steady-state plasma accelerator QSPA device and its operation, as well as some possible applications of powerful plasma streams generated by QSPA, are described in this paper. The main attention was paid to plasma parameters, measurements in the different regimes of operation, analysis of efficiency of powerful plasma streams, penetration into mirror magnetic field, and plasma magnetization taking place under their propagation along the uniform magnetic field is carried out. Some results of thermal quench disruption simulations carried out with irradiation of solid targets by high energy plasma streams are presented in this paper. And that's from www.scielo.br, and then a long string of other numbers. There's their diagram. And this is a block diagram of the QSPA KH50 device. It's number one is the anode transformer. Number two is the anode collector. Number three is the anode transformer pies. 4 is the cathode transformer rods. 5 is the anode ionization chamber. And 6 is the drift channel. 7 is the input ionization chambers. 8 is the needle type emitters. Okay, there's all the little words there. More graphs. There's that there. And this is called the radial distributions of magnetic field and plasma streams normalized to vacuum magnetic field values for the first operation regime. There's another graph here for you to look at. And this one says plasma density and dependence of distance from the graphite target surface. And there's the calculations from the beginning of a plasma interaction with the surface, and another equation there. Okay, so distance along the target, there's another diagram, and it says erosion profiles of quartz surface 90 by 90 millimeters for different cross sections, inclined incidence of plasma. Then there's the comparison of numerical simulation and experimental results. It's talking about graphite erosion, quartz, and copper and aluminum. And there's the different numbers that they came up with for them. My thoughts. The 6.5 pulse in the quartz erosion is a keyword. It came up with the ATLAS experiment results at CERN, where they need to change something for the Higgs boson particle. Instead of 6.5, make the pulse 6.4, see the graphs below. The test results and procedures for these need to be repeated with this pulse quartz plasma data from QSPA. See the PDF Quasi-Steady-State Plasma Accelerator for Fusion Experiments, Data and Mix, the ATLAS Tevatron Fermilab and CERN data together, combined with the new formula ideas for the Higgs boson particle, the one that says we can prove it exists. Okay, so here's the ATLAS preliminary for the Higgs mass. Okay, it says ATLAS BB Higgs boson decay into bottom quark pair in conjunction with WZ boson, no excess 20 standard model Higgs signal VHH hydrogen to BB add deuterium for 14 TeV. Okay, this is this one here. It says ATLAS YY Higgs boson particle data, wow, new formula, preliminary data 2011, 7 TeV FLDT 108 FB, which is this one here, should be 6.04. So you want to do whatever you got to do to get that to 6.04. August 20th, 2012, my thoughts. The type of graphite surface to use is found in the WOW SETI videos obsidian. That's the key word. Cross-reference the word graphite in WOW SETI data. 23 videos come up with the word graphite in them. The keywords come up in the following videos found on the Ideal Girl Says YouTube channels with formulas. The first one is line 18A, 3W4, uranium neutrino split, Z bosons, weak atomic 5G UFO WOW SETI. On the 25th of June 2012, the keywords from the data found. Okay, today's September 17th, but this is the data back from June 2012, okay? So line 22E10A, neutron, triton, binding energy, lithium-7 scattering, 5G WOW SETI. These are the titles of the videos you need to look for. Line 22E10A, neutron, triton, binding energy, lithium-7 scattering, 5G WOW SETI. Formula with scattering methods and keywords in the data from WOW SETI video. June 25th, 2012, keywords from the data found. In line 22E10A, neutron, triton, binding energy, lithium-7 scattering, 5G WOW SETI. So I went to the video and looked at the notes that came with it, and this is the formulas from that particular video. It said mass plus hydrogen plus helium plus slower neutron plus inelastic scattering plus neutron plus backscattering techniques plus matter plus proton plus triton plus 3H plus reaction plus ionized gas inside. So we have a cold thermal neutron, we add hadronic weak interaction, add the standard model test measurements, plus neutron decay, plus neutron polarization, plus Mach-Schwinger scattering of polarized neutrons, plus produce spin-dependent shifts in beam centroids, plus produce significant systematic effects experiments, plus calculation, plus process for neutral atoms, plus molecules, add the low neutron energies, plus electromagnetic Mach-Schwinger. Then you want to do neutron scattering, add the condensed matter, add classical neutron diffraction plus spatial distribution in the outer electron shells, and I'm running out of battery power. So I add combined X-ray neutron diffraction plus diffraction of polarized neutrons. Neutron radiographic image degradation is scattering blur from the object. I'm going to add eliminating the overlapping of scattered thermal neutrons component from the objects in ETRR. 2. Neutron radiography facility using aluminum GD coated anti-scatter grid. I'm probably going to have to continue the rest of this video in another video segment because I'm running out of battery power, okay? So just look to the one that it's connected to on the Ideal Girl Says YouTube channel. So MCNP code plus optimum grid dimensions that will reduce scattered thermal neutrons from the object, plus optimum grid height and irradiation time, plus best image plus geometric sharpness, plus MCNP code plus scattered neutrons were removed.